So the mean of all quantitative scores on the GRE is 150.8 with a standard deviation of 8.8. Scores on the quantitative portion of the GRE are approximately normally distributed with mean.
Mm-hmm.
Wouldn't that just be the 150.8 and the 8.8?
Yeah.
Okay. And then part 6B. What proportion of the people who take the quantitative portion of the GRE will score above 165? So that's the Z-score, correct?
Yes.
Okay, so we have, so you take the 165 and then minus that by the 150.8, right?
Mm-hmm.
Which gives us 14.2. 65 minus 50.8. And then we divide that by 8.8. Is that right?
Yes.
Okay.
Yep.
So that gives us 1.614. Is that what you got?
See, as the probability or the, oh yeah, I got 1.614.
Okay, so that's the Z-score. And then hold on. And then it's the probability, right? So then do we put it into that thing? Like we put the Z-score of the 1.614 into that applet?
Yeah, into a little graph.
Yeah. And then
And then the area will just be above 1.614, and the area would be 0.0533.
yeah. So when you shade that in the applet, do you have just the stuff to the left or to the right when they're asking that?
To the right.
To the right? So it's just that, like, from the red line to basically 3 or whatever?
Yeah.
Okay. All right. And then the next question was, if a student scores in the 10th percentile, what would their corresponding Z-score be?
Let me see. I'm trying to figure out how to use 10th. 10th of something. Let me see.
What's the student scores? Oh, I know. I'm trying to like make my brain think of how to switch it into. Hold on.
Yeah.
Okay, percentiles. Okay, so we need to just put it in as so 0.100 in the area. 0.100.
Oh, okay, that works.
Yeah. And then well, it gives us a Z-score of 1.28 something. I mean, 1.282 is what my little applet says. And it's not unusual because it's under 2. Or it's negative.
Yeah.
Okay, wait. Yeah. Wait, did the... Okay. Does that make sense? Does that work?
Yeah. Yeah, that's just kind of confusing a little bit.
1 point. Okay. All right. And then what is the quantitative GRE score for the student who scores in the 10th percentile? So
I think you just use it backwards. So it is, let me see. So you'd have negative 128.16 times 8.8 plus 150.8, and then you get 139.5, which would be like 140.
okay, wait, so explain to me or show me how you figured that out again.
So let me see. So I guess go to the preparation thing and go part 1, number 4. It's got the formula.
So part 1.
It's just like z-score formula. So I used to take chemistry a lot. So it goes, if you can't find the answer, then you have to go backwards to the answer you have. So you have the z-score, the mean, and then the standard deviation. So you just go backwards. So you would times the z by the standard deviation, and then add it by the mean, and then you would get z and x, which would be like what the score would be.
Okay, I'm still not following. You said so where's the in the reading there's a formula?
Here, let me see where. So look at the end of the reading. So at the end of the reading, it's the z-score formula.
Which section is that, or do you
just go the very end
to the summary?
For the summary, remember?
Okay.
So you have the z-score, and you have the mean, and you have the standard deviation, but you don't have the value. So you take the z, multiply it by standard deviation, and then you add the mean to that, and all that's left on that side is value, which we don't know. So then that's how you get the value of what it would be.
Okay, so RZ, that was the 1.614. Is that right?
Yep.
You took the 1.614 and then multiplied it by, what was the standard deviation in this one?
It was 8.8.
Okay. By 8.8, and then you added to that?
And you add the mean to that, 150.8.
That gives you 165?
I think you forgot to make 1.2816 negative. So instead it was a positive.
So say that one more time, sorry.
So take negative 1.2816. And then
negative 1 point what? Sorry, where are you getting?
So I'm just taking the numbers that we got from C. I'm sorry, 6 from question 6C.
Oh,
So
okay.
this is
So
yeah,
you got
so
negative 1.2.
816.
Okay.
And times that by 8.8.
Okay.
And then add 150.8.
And that gives us the 139.5, so 140.
Yes.
Which rounds to 140. Okay. Okay, that makes more sense. I was totally lost. I was actually looking at the z-score from the last problem. That's where I messed up.
Oh, okay.
Okay. I'm like, this isn't like adding up. And then I was looking at the wrong one. Okay. So then 7, the mean speed of hydrogen at room temperature is 1800. Is that milligrams per second? I don't know. With a standard deviation of 600. At room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of, so that was the 1800, right?
Yeah.
Okay, and then per second and a standard deviation of 600. 600. Okay, so then what is the probability that a randomly selected particle has a speed over 2500? So do we figure out the z-score first? Wait, what did it say? Hold on. There's a probability. Okay, so, or do we just throw in that, let's see. Trying to figure out.
Yeah.
So it says, sorry, I don't know where my, oh, there it is. Okay. So what is the probability? 2500.
Which one do you want again?
I think 7B.
Okay, so you're taking, you're gonna take 2,500 minus it by,
minus the 1800
yeah.
and divide it by the 600.
Yes.
Okay, so that's 2,500 minus 1,800. So that gives us 1.1667.
Yes.
Okay.
And so then that gives us the probability of 0.1216. And then the next answer is just the reverse. So then.
So wait, how did you get the probability? Did you throw that into that little?
Yeah, I threw it into the graph.
Where did the graph go? In the world.
It's right above 3.2.
So you just put in, okay, so then you put in -1. That gives us the 1.121. I got 0.6, but okay. Okay, and then see what's the probability that randomly selected particle has a speed that is less than. So then you just shaded. Well, wasn't it the same?
For the next answer, it's you just shade in everything but the what's after the right line. So even like, and you can just minus it by 1 even to get the other probability.
So you shaded in the 2 like to the left of the red line of the far right line?
Yes.
Okay. This answer is easier to get by subtracting the answer to part 1A from 1. So part 1A. Hold on, sorry. Let me see something real quick. I'm just trying to see what they're saying.
Yeah.
Oh, okay. Okay. And then G, what is the probability that a randomly selected particle has a speed that is less than 1,500? So do we just go back in and put it in 1,500?
Same thing with 1,500.
So you just do the same thing that we did with 2,500, but with 15?
Yes.
Okay. Let's negative 0.5. And then okay. Okay, and then what is the probability that a randomly, okay, we did that. Oh, that's the one where you just take it and subtract the 2, right? So it was, I think, right, we take the 0 point, because when you're trying to do it between the 2, we take the 0.8783 and minus the 0.3085 to give us that. Yeah, that's what it is, right? For E?
Yeah, that's right.
So 0.5698. Okay, and then F, what is the third quartile of the speeds of hydrogen at room temperature? So is that everything to the right of the 0 point? Yeah, I don't know how they got that. 0.5698.
Yeah, I don't know how they got that either. Let me see. I was like, because that was one of the harder ones.
Third quartile of the speeds of hydrogen is 2204.4. I don't know how they got that. Third.
Okay, they're looking for the speed. That's the mean speed, and that's the standard deviation speed. Okay, let me. Yeah, that's really confusing.
No, I'm trying to see. Oh, wait. Third quartile. So do we just put in 75 into the? Does that make sense?
Yes, yeah.
What was the answer that they got? No, that's not what it was. Okay. Ugh. I can't even see anything about figuring out like quartiles in the reading. Do you?
Oh, now I found it. Okay, so you're right. So you plug. It was just like the last answer.
Okay.
You plug 0.75
into the area,
and then you take the z score, and then you plug it back in to find the value. And I got 2,204.4.
Okay, so you did that. So z equals 0.674, and then the mean was
1,800.
And then we don't know what the other one is, right? What's it called?
Yeah, we don't know what the value is, so we don't know the standard deviation is.
We don't know the standard deviation? I thought it was 600.
Yep, we do know it. That's what I mean.
Okay, so you took 0.674 and you times that by 600?
Yes.
And then you added the 1,800?
Yep.
To give us, yep, okay. There you go. Look how smart you are. Okay. Okay.
And then laughs forward about which one's normally distributed and which one's not.
If the data follow a normal distribution, then we expect these points to lie in a straight line. If the data are non-normal, we expect to see a distinct curve. So plot A should be not normal, right? Because it doesn't do a curve.
A is not normal, right? Because you can see the dot all the way to the side. Like if that wasn't there, it'd be like more normal, but it's very far out there.
Oh, because of that dot on the far right?
Yeah.
Okay.
And then B, I put it's not normal because it did the same thing. It has a longer curve outside the line.
Okay.
C,
it doesn't.
Most of the points
lie on the line.
So normal.
And then same with D.
Yeah.
Okay. And then
yeah.
And then D would also be normal, right? Because it's on the line.
Yeah.
And then E would be not because it goes outside. And then F. Does F, is that normal if it goes outside of the line at the end and at the beginning? Like because the majority of it's on the line?
I'd say I put normal because even though it is curved out, it's not curved out far enough and it's more condensed.
In the middle?
Yeah.
Okay. Yeah, I agree. And that's okay. All right, are we ready to take the quiz? I'm a little scared. I'm gonna be honest.
Yeah, these ones are weird.
Yeah, my brain doesn't really like function the same. I don't know. I don't have a math brain. That's why I married a doctor. I was like, well, one of us can help kids with homework. It's not me.
Yeah.
Okay. So let's go to lesson 5. So that. Are you going to the quiz?
Yeah.
All right. My hands are sweating. I don't know why they're sweating.
Yeah.
Okay. I completed. Actively participated. Okay. Needed the normal probability apple. I'm going to just pull that up just so we have it. Okay. And then when calculating anything, please remember to round to 3 decimal places unless otherwise specified. Do not round until your calculation is complete. I did that on the other quiz. I put in as a percentage. I didn't read through that part. I missed that it needed to be as a decimal and not a percentage. So lesson learned. Okay. So does yours have a graph on it?
No.
Okay.
It's has a link if you want to pull up that little normal probability, but it's already in the meeting. So
the total area under a normal distribution curve must equal, wasn't it 0 to 1? Isn't that right? No?
It's supposed to equal 1 because the whole area is 1. Because when you add up this area with this area, that's the whole curve. It has.
Okay.
Let's see. Next one is under certain circumstances, a normal distribution curve can drop below the x-axis. I put false.
Yeah. Because it says it's not supposed to, right?
Yeah. It's supposed to stop at the x-axis. And then next one, a normal distribution curve is symmetric. But yes.
Yeah.
Okay, next one is a little picture. Do you see the picture?
Yeah, I opened it in a different web browser and it's working.
Okay. And it says the following, which represents the z-score. I think that's C.
Yeah.
And then which of the following elements of the figure represents the probability that
that's B
greater than 1? I put, I think it's none of them. Wait, let's see. So if it's probability that z-score will be greater than 1, oh wait, that's right, probability. That's it's different. So I put, yeah.
Is it B?
Yeah, it is B. Sorry, I thought of it said the probability would be 1.
Okay.
But that's B.
Okay.
And then
68, 95, 97.
68, 95, 99.7 roll. What a percentage of the data from the bell-shaped distribution will be within 1 standard deviation of mean? Write down it as a percentage.
Hold on. I can't remember what that was. 1 sec.
Okay, let's see. Be within 1 standard deviation of the mean.
Okay, hold on. So I remember reading it, but I can't remember what the answer what was the 40 Okay. 68% of the data will lie within one standard deviation, 95, blah, blah, blah. Is it just 68%?
I'm not sure.
Let's see, let me read through that again. According to the 68, 95, 97 rule, what percentage of the data from a bell-shaped distribution will be within one standard deviation of the mean? Okay, so within one standard deviation. Is that pretty sure it's like the 68. But
So I'm trying to figure out too. The reading behind the rule is kind of weird. I think you're right. It's 68 because 68 of the data will lie within one standard deviation of the mean.
that's what I'm thinking, right?
Yeah.
Okay.
And then next one is suppose that the z-score from the standard normal distribution, what proportion of the z-score will lie between -1 and 1? So I guess.
Suppose that z-scores from a standard deviation. So do we put in just the 68% in that probability? You know what I'm talking about? So 0.68?
No, so you just put in the z-score 1, and so go 1, -1, and then you just have the little area in the middle
Highlighted.
And what I was 0.6827, which would be 0.683.
Yes. 0.683.
Then next one, what proportion of the z-score will lie between -2 and 2? So
go back and do the same thing. Just put the -2.
Yeah, and that's
2.0, right?
Let me see again. Yeah, 2.0.
0.955.
That's right. Okay, it's like the same thing for the next one for 3.
Okay, hold on. Oh, okay.
And for 3, the area is 1.
For 3, I got 0.997.
Let me see it again. Okay, 3.
Which would make sense because that would be the 99.7%.
Yeah.
So 0.997, right?
Let's see, I just gotta click those tiny little boxes. Yep, 0.9973.
But we only have to round to 3, right? So 0.997.
Yes.
Yeah.
Let me see, look carefully at your answers.
So we already know it matches the 68, 95, and 97.
Yeah. So
right?
it's yeah.
Okay.
So look carefully at your answers to the 3 questions. What do you observe? Let me see. So
I think it's A because the values match.
yeah. Let me see.
As the z-score increases.
Yeah, that answers do match.
Bigger. Yeah. I think it's A.
Okay. So next one.
Following information. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram of body weight. Gram P times K, whatever. The population mean protein requirement for adults is 0.65. So I'm just writing down the mean is 0.65. And the population standard deviation is 0.07. What proportion of the population have a protein requirement that is less than 0.60 grams? Okay. So do we figure out the z-score and then put it into that probability applet?
Yes.
Okay, so we take 0.60 minus the 0.65 and divide it by the 0.07. Okay, so 0.60 minus 0.65. I got negative 0.714. Is that what you got?
Yes.
So then we type in the z-score of 0.714 and less than 60.
So I put the negative 0.714.
Okay.
And that's below. In that area, I got 0.23676.
Yep, that's what I got.
238.
So 0.238.
Yeah. Okay, and then the next one is like the inverse, but I'm still going to go to the graph. The inverse of that would be.
Is it the same thing?
It's like the opposite. So you just minus it by 1. So it's going to be 0.762.
Okay, wait. So you subtract. Wait. You subtract the 0.5248 by the 0.714.
So you take the answer from 13, which is 0.238, minus it by 1, and then that will give you the answer of the probability higher than 0.60.
So it's negative 0.762?
Sorry, it's not negative. It's just like it's 0.762.
Oh, so you take 1 minus the 0.238.
Yeah.
So it's 0.762?
Yes. Okay, so next one is 0.7 minus 0.65 divided by 0.07. So it's like the same answer for the next one. Just
it's still 0.714, right?
Yeah. So we're going higher than that. Let me see. Let me just make sure. Yeah, if we're going less than, never mind. It's yeah, it's 0.762. Okay, let me try that again. Okay, so want less than 0.7 minus 0.65 divided by I remember.
0.7.
7. Yeah, I get 0.714 again.
That's what I got too.
I guess I'll just put it in.
So 15 we're going to put as 0.714.
We're going to put the probability 0.762 like the last answer. Because I guess 0.60 is 0.762, and then what, lower than 0.70 is like 0.762 in the same way.
Mm-hmm.
It's weird. All right.
So
16.
0.762.
Yeah. Okay, so find the probability that a randomly selected person will have a protein. Sorry, let me mute that.
Okay.
Sorry about that. My dog barks every time someone comes to the door.
So does mine. So does mine.
Okay, so find the probability that a randomly selected person will have between. Remember that you find.
Subtract the two.
If they're the same, actually, then you just take the graph of negative 0.714 and then positive 0.714. It should be 0.525.
So what, you took that? I got 0.475.
What are the z-score?
0.714.
So is the part in the middle just blue?
No, I had the outsides blue.
Okay, you want the middle one blue.
Okay. And that's the 0.525.
Yes. Okay, so the next one is going to be like we did before. Going to put 35, so 35 percentile. So that's going to be negative 0.385.
Hold on, I got. Hold on.
So put 0.35 in the area.
0.35.
And then you're going to get a z-score of, what we're looking for is negative 0.385. Negative
0.325. Or why it's throwing. What in the world? 35th percentile. Mine, like when I type it in, it keeps going to 1.
What do you have? What's the blue shaded part?
Oh, I've got the center.
Yeah, so just shade the bell part on the far left because that's a 35 percentile.
Okay.
And just like focus on the z-score, it should be just 0.385.
Yep.
So then you take the negative 0.385 times it by 0.07, and then you add it to 0.65, and what I got is 0.623.
So negative 3.5, and you multiplied it by the 0.07, and then you added the 0.65?
Yes.
To 0.623?
Yep, that's it.
Okay.
All right, now we're looking for the
80th.
80th percentile.
So the stuff to the right of the curve?
Mm-hmm. So that would be 0.842 z-score.
Yep.
Then
so we just do that same thing, the 0.842, multiply it by the 0.07, and then add the 0.65, so 0.7089. So 0.709?
Yes, 0.709.
A witness testify about liens.
All right. I didn't write down the answers this time, but I think they should be right. So, you okay submitting it?
Yeah.
Okay, mine's going to be a little slow.
Okay. Nope, we got it.
All correct?
Yeah.
Awesome.
Sweet. Okay. Thank you. That was super helpful. I'm glad we had a group meeting today.
Yeah.
Okay. I will submit it, and then I'll shoot a text out to everybody to see if we're still planning on meeting Tuesday this next week.
Okay.
Right? Was it Tuesday or was it Monday? Monday and Wednesday? Now I don't remember.
Well, I remember we wanted to do Tuesday, Monday, like Monday, Tuesday, so I had an issue, so we're gonna like Monday, Wednesday.
Yeah.
I guess let's coordinate.
Okay. Okay, I will check with the rest of them to see if that's still cool. I think I have like once a week I have another meeting at 2:30 on Wednesdays. So I wonder if we should do like a half hour earlier. I don't know. I'll send out a group text and just see what works for everybody.
Okay.
All right. Okay. Thanks, Max. Have a good weekend.
You're welcome. You too.
All right. Bye.
Bye-bye.